Hi everyone, I am Ivy Jean Elamigo and I'm going to report Chapter 9, Capacity and Level of Service for Highway Segment. The fundamental diagram of traffic flow was used in Chapter 6 to illustrate the relationship between flow and density. It was shown that traffic flows reasonably well when the flow rate is less than at capacity. But excessive delay and congestion can occur when the flow rate is at or near capacity. Capacity analysis therefore involves the quantitative evaluation of the capability of a road section to carry traffic, and it uses a set of procedures to determine the maximum flow of traffic that a given section of highway will carry under prevailing roadway traffic and control condition. As discussed in Chapter 6, the level of operating performance changes with traffic density. The measure of quality of flow is the level of service, or LOS, a qualitative measure ranging from A to F that characterizes both operational conditions within a traffic stream and the highway user's perception. This chapter presents a procedure for determining the level of service and other performance measure of uniform road segments on two-lane and multi-lane highways and freeways. Two-lane highways. The procedures developed for two-lane highway segments provide the basis to evaluate level of service and capacity. For highway segments, there are two levels of analysis. One is operational and two is planning application. Operational level of analysis. Level of service is determined based on existing or future traffic conditions and specific roadway characteristics. The Highway Capacity Manual, or HCM, procedures is designed to analyze two-lane highway segments for two-way traffic, for a specific direction, and for a directional segment with a passing lane. If the terrain is mountainous or if the segment length to be analyzed is greater than 0.6 miles and the grade is at least 3%, two-lane highways are analyzed as specific upgrades or downgrades. Planning applications correspond directly to the procedures used for operational analysis but use estimates and default value in calculations. Two classes of two-lane highways are analyzed. They are defined according to their function in the following manner. Class 1, two-lane highways that function as primary arterial, daily commuter routes and links to other arterial highways. Motorist expectation are that travel will be at relatively high speed. Class 2, two-lane highways where the expectation of motorists is that travel speeds will be lower than for Class 1 roads. These highways may serve as access to Class 1 two-lane highways. They may serve as scenic byways or may be used by motorists for sightseeing. They also may be located in rugged terrain. Average trip length on Class 2 highways are shorter than on Class 1 highways. Planning level of analysis. Operational procedures are followed but with estimates, HCM default values, and local default values. Annual average traffic, or AADT. Values are used to estimate directional design, hour volume or DDHV. There are two measures used to describe the service quality of a two-lane highway. One is percent time spent following another vehicle, or PTSF, is the average percentage of time that vehicles are traveling behind slower vehicles. When the time between consecutive vehicles, called the headway, is less than 3 seconds, the trailing vehicle is considered to be following the lead vehicle. PTSF is a measure of the quality of service provided by the highway. Average travel speed, or ATS, is the space mean speed of vehicle in the traffic stream. Space mean speed is the segment length divided by average time for all vehicles to traverse the segment in both directions during a designated interval. ATS is a measure of the degree in which the highway serves its function of providing efficient mobility. The relationship between ATS and PTSF for two-way segments are for base conditions defined as the absence of restrictive geometric, traffic, or environmental factor. Base condition exists for the following characteristics: are level terrain, lane width 12 feet or greater, clear shoulders 6 feet wide or greater, passing permitted with absence of no passing zone, no impediments to through traffic due to traffic control or turning vehicles, passenger cars only in the traffic stream, equal volume in both directions for analysis of two-way. Capacity of a two-lane highway is 1,700 passenger car per hour for each direction of travel and is nearly independent of the directional distribution of traffic. For extended segments, the capacity of a two-lane highway will not exceed a combined total of 3,200 passenger car per hour. Short sections of two-lane highway such as a tunnel or bridge may reach a capacity of 3,200 to 3,400 passenger cars per hour. Level of service expresses the performance of a highway at traffic volumes less than capacity. LOS for Class 1 highways is based on two measures, PTSF and ATS. LOS for Class 2 highways is based on a single measure, PTSF. Level of service criteria are applied to travel during the peak 15 minutes of travel and on highway segments of significant length. Level of service designations are from A, highest, to F, lowest. Definition of LOS and appropriate ranges for PTSF and ATS values are as follows. Level of service A. This is the highest quality of service that can be achieved. Motorists are able to travel at their desired speed. Class 1. Highway average travel speed ATS is 55 miles per hour or greater, and travel delay PTSF occur no more than 35% of the time. Class 2 highway maximum delay PTSF is 40% of the time. So under base condition is 490 PC per hour. For level of service B, the At this level of service, if vehicles are to maintain desired speed, the demand for passing other vehicles increases significantly. Class 1, the ATS are 50 to 55 miles per hour, and travel delays is between 35 and 50% of the time. For Class 2, the PTSF is 40 to 55% of the time, and under base condition is 780 PC per hour. Level of service C, further increases in flow beyond the LOSB range result in a noticeable increase in the formation of platoons and an increase in platoon size. Passing opportunities are severely decreased. So Class 1, the ATS are 45 to 50 miles per hour, and travel delay is between 50 and 65% of the time. Class 2, the PTSF is 55 to 70% of the time, and under base condition is 1,190 PC per hour. Level of service D. Flow is unstable and passing maneuver are difficult, if not impossible to complete. So Class 1, the ATS are 40 to 45 miles per hour, and travel delays between 65 and 80% of the time. So Class 2, PTSF is 70 to 85% of the time, and the maximum service flow rate under base condition is 1,830 PC per hour. Level of service E. Passing has become virtually impossible. Platoons are longer and more frequent as slower vehicles are encountered more often. Class 1, the ATS are 40 miles or less, and travel delays occur more than 80% of the time. Class 2, the maximum delay is greater than 85% of the time, and the service flow rate is 3,200 PC per hour. Level of service F. Traffic is congested with demand exceeding capacity. Volumes are lower than capacity and speed are variables. So, example 1. Determine the level of service of two-lane road if PTSF and ATS are known. So, ani, di ba kay na may mga may segment dire, segment 1, 2, 3, and 4. So, napoy given diri nga PTSF o ATS. So, ang atong himuon is ato orang i-identify kung kaning segment 1 unsa ni siya nga LOS. So, based sa previous nga discussion nga ahong sulti, so ang segment 1 is LOSB. Then segment 2 is LOSC. Segment 3 is LOSD, and segment 4 is LOSE. Procedure for determining level of service. The procedure for determining the LOS of a two-lane highway are carried out separately for the following cases. 1 is two-way segments located in a level or rolling terrain. Grades are 1 to 2%, and heavy vehicle maintain the same speed as passenger cars. Number 2 is directional segments, for which the LOS is determined for traffic in a single direction. Any segment can be analyzed as a directional segment. The procedure is used to analyze extended directional segments. Specific upgrades or downgrades defined as two-lane highways located in mountainous terrain or with grades that exceed 3% in segments exceeding length of 0.6 miles and passing lane for relatively short uniform segments. The analysis of two-lane road for two-way segment is usually performed on extended length when the segment length is at least 2.0 miles and the segment is located in level or rolling terrain. Level terrain. Segments contain flat grades of 2% or less. Heavy vehicles are able to maintain the same speed as passenger cars throughout the segment. Rolling terrain. Segments contain short or medium length grade of 4% or less. Heavy trucks speeds are lower than passenger cars but are not at crawl speed. If the grade exceeds 4%, the two-way segment procedure cannot be used but must be analyzed during the specific grade procedure for directional segments. Calculating the value of PTSF for two-way segment. So PTSF is equal to BPTSF plus FD over NP, where BPTSF is equal to the base percent time spent following for both directions and is computed. So BPTSF is equal to 100, 1 minus e raised to negative 0.000879 VP. So FD over NP is adjustment in PTSF to account for the combined effect of percent of directional distribution of traffic and percent of no passing zone. VP is passenger car equivalent flow rate for the peak 15 minutes period. So VP is equal to V over PHF times FG times FHV. So V is demand volume for the entire peak hour. So PHF is peak hour factor. FG is grade adjustment factor for level or rolling terrain. And FHV is adjustment factor to account for heavy vehicles in the traffic stream. So FHV is equals to 1 over 1 plus PT times ET minus 1 plus PR times ER minus 1. PT and PR are the decimal portion of tracks and RVs in the traffic stream. For example, if there are 22% tracks in the traffic stream, then PT is 0.22. ET and ER. The passenger car equivalent for trucks and RVs respectively values are provided in table 9.5. Example, determine the value of PTSF for a 6-mile 2-lane highway in rolling terrain. Traffic data are as follows. So, the volume is 1,600 VEH over H. Then percent trucks is 14, percent RVs is 4, peak hour factor is 0.95, percent directional split is 50 minus 50, percent no passing zone is 50. So, using the formula, so i-substitute na nato itong mga value nga gihatag. So, sa VP is 1,600 over 6.95, so equals 1,684 PC per hour. So, ang FG is 1, then ET is 1, and ER is also 1. So, in getting the FHV, so 1 over 1 plus 0.14 times 1 minus 1 plus 0.04 times 1 minus 1 equals 1,000 684 pc per hour. Since 1,684 is less than 3,200, this section is operating below capacity. So, BPTSF is equals to 1,000 times 1 minus E raised to negative 0.000879 times 1,684. So, the BPTSF is equals to 77.2%. So now, we're able to get the PTSF, which is equals to BPTSF plus FD over NP. So FD over NP is equals to 4.8. So PTSF is equals to 77.2 plus 4.8. So PTSF is equals to 82.0%. Three categories of directional segments are considered. Extended segments located in level or rolling terrain with a length of at least 2 miles. Specific upgrades or downgrades located in mountainous terrain or with grades of at least 3% for segment length of at least 0.6 miles long. A passing lane added within a section in level or rolling terrain or as a track climbing lane. Calculating the value of PTSF for directional segment in level or rolling terrain. So, PTSFD is equals to BPTSFD plus FNP, where BPTSFD is equals to 100 times 1 minus E raised to AVB over D, and PTSFD is percent time spent following in the direction analyzed. FNP is adjustment for percentage of no passing zone in the analysis direction. VD, passenger car equivalent flow rate for the peak 15 minutes period in the analysis direction. A and B is equals to coefficient based on peak 15-minute passenger car equivalent opposing flow rate, VO. Calculating the value of ATS for directional segment in level or rolling terrain. The average travel speed for a two-way segment is computed by using ATSD equals FFSD minus 0.00776 times VD plus VO minus FNP, where ATSD is the average travel speed in the analysis direction of travel. FNP is adjustment for the percentage of no passing zone in the analysis direction. FFSD is the free flow speed in the analysis direction. Freeways. A freeway is a divided highway with full access control on two or more lanes in each direction for the exclusive use of moving traffic. Signalized or stop controlled at grade intersection or direct access to adjacent land use are not permitted in order to ensure the uninterrupted flow of vehicle. Basic freeway sections are segments of the freeway that are outside of the influence area of ramps or weaving areas. Merging or diverging occur where on or off ramps join the basic freeway section. Weaving occur when vehicles cross each other's path while traveling on freeway lanes. Base free flow conditions include the following freeway characteristic. Lanes are 12 feet wide, lateral clearance between the edge of a right lane and an obstacle is 6 feet or greater. There are no trucks, buses, or RVs in the traffic stream. Urban freeways are 5 lanes in each direction. Interchanges are spaced at least 2 miles apart. Grades do not exceed 2%, and drivers are familiar with the freeway. The capacity of a freeway is the maximum sustained 15 minutes rate of flow, expressed in passenger cars per hour per lane, which can be accommodated by a uniform freeway segment under prevailing traffic and roadway conditions in one direction. Condition of free flow speed occur when flow rates are low to moderate, less than 1,300 pch ln at 70 miles per hour. As flow rates increase beyond 1,300, the main speed of passenger cars in the traffic stream decreases. Level of service for freeway segment. Level of service, or LOS, qualitatively measure both the operating conditions within a traffic system and how these conditions are perceived by drivers and passengers. Lane width. Traffic flow tends to be restricted when lane width are narrower than 12 feet. This is because vehicles have to travel closer together in the lateral direction, and motorists tend to compensate for this by reducing their travel speed. Lateral clearance. When roadside or median objects are located too close to the edge of the pavement, motorists in lanes adjacent to the object tend to shy away from them, resulting in reduced lateral distances between vehicles, a result similar to lane reduction. Vehicle equivalents. The presence of vehicle other than passenger cars, such as trucks, buses, and recreational vehicle in a traffic stream reduces the maximum flow on the highway because of their size, operating characteristics, and interaction with other vehicles. Grade. The effect of a grade depends on both the length and slope of the grade. Traffic operations are significantly affected when grades of 3% or greater are longer than 1/4 miles and when grades are less than 3% and longer than 1/2 miles. Speed. Space mean speed. Driver population. Under ideal condition, the driver population consists primarily of commuters. Interchange spacing. Short freeway sections, as found in urban areas, operate at lower free flow speed than longer ones, where interchanges are less frequent. The ideal spacing is 2 miles or more. The minimum average interchange spacing is 0.5 miles. The relationship between the three performance characteristics is as noted in D is equals to Vp over S. So Vp is flow rate, S is average passenger car speed, D is density defined as number of car per miles. The definition of level of service A through F is as follows. Level of service A, free flow operations in which vehicles are completely unimpeded in their ability to maneuver. LOSB, traffic is moving under reasonably free flow conditions and free flow speeds are sustained. LOSC, speed are at or near the free flow speed, but freedom to maneuver is noticeably restricted. LOSD, speed can begin to decline slightly and density increases more quickly with increasing flows. LOSE, operations are volatile because there are virtually no usable gaps. LOSF, operation is under breakdown condition in vehicular flow. Calculating the flow rate for a basic freeway section. So, Vp is equals to V over PHF times N times FP times FHV. So, Vp is 15 minutes passenger car equivalent flow rate. V is hourly peak vehicle volume. PHF is peak hour factor, and N is number of travel lanes in one direction. Extended general freeway segment. This occurs when a single grade is not too long or steep to have significant impact on capacity. PCE values are affected by the type of terrain, which is classified as level, rolling, or mountainous. Freeway segments are considered to be on level terrain if the combination of grades and horizontal alignment permits heavy vehicle to maintain the same speed as passenger cars. Freeway segments are considered to be on rolling terrain if the combination of grades and horizontal alignment causes heavy vehicle to reduce their speed to values substantially below those of passenger cars but not to travel at crawl speeds for any significant length of time. Freeway segments are considered to be in mountainous terrain if the combination of grades and horizontal alignment causes heavy vehicle to operate at crawl speed for a significant distance or at frequent intervals. Crawl speed is the maximum sustained speed that track can maintain on an extended upgrade of a given percent. PC is for specific upgrades. Any freeway grade of 3% or more and longer than 1/4 mile, or a grade of less than 3% and longer than 1/2 mile, should be considered as a separate segment. PCAS for specified downgrades. If the downgrade is not so severe as to cause track to shift into low gear, they may be treated as if they were on level segment. Composite grades. When a segment of freeway consists of two or more consecutive upgrades with different slope, the PCA of a heavy vehicle is determined by using one of two techniques. Calculating the average passenger car speed S, density D, and level of service LOS for a basic freeway section. Average passenger car speed S is depicted and is one of three variables that can be used to determine the level of service. The value of APCS is a constant equal to the free flow speed FFS up to a value of 1,300 pc per hour at a FFS of 70 miles per hour. In order to conduct a capacity analysis, compute VP and obtain the average passenger car speed S from the formulas used in the Highway Capacity Manual. Four types of problems are solved by capacity analysis. Type 1, given highway volume, number of lanes, and free flow speed, determine level of service. Type 2, given highway volume, level of service, and free flow speed, determine the average speed. Type 4, Given the level of service and free flow speed, determine the hourly flow rate. And type 4, given the highway volume, free flow speed, and the desired level of service, determine the number of freeway lanes required. Free flow speed, or FFS, is equals to BFFS minus FLW minus FLC minus FN minus FID. So FFS is free flow speed, BFFS base free flow speed, FLW adjustment for lane width, FLC adjustment for right shoulder lateral clearance, FN adjustment for number of lanes, FID adjustment for interchange density. Adjustment for lane width, when the average lane width of the freeway is less than the ideal value of 12 feet, the free flow speed of 70 or 75 miles per hour will be reduced. Adjustments for right shoulder lateral clearance. The ideal clearance condition are 6 feet on the right shoulder side of the freeway and 2 feet on the left median side. Adjustment for number of lanes. If the number of freeway lanes in one direction is less than 5, the free flow speed is reduced on urban and suburban highways. Rural freeways are usually 2 lanes in one direction and the speed reduction value is 0. Adjustment for interchange density. The ideal interchange spacing is 2 miles or greater, or 0.5 interchanges per mile. When the number of interchanges per mile increases, there is a corresponding decrease in free flow speed. Multi-lane highways. Multi-lane highways differ from 2-lane highway by virtue of the number of lanes and from freeway by virtue of the degree of access. They span the range between freeway-like condition of limited access to urban street condition with frequent traffic-controlled intersection. Multi-lane highways may exhibit some of the following characteristics. Posted speed limit are usually between 40 and 50 miles per hour. They may be undivided or included medians. They are located in suburban areas or in high-volume rural corridors. They may include a two-way left or median lane. Traffic volumes range from 15,000 to 40,000 per day. Volumes are up to 100,000 per day with grade separation and no cross-median access. Traffic signals at major crossing points are possible. There is partial control of access. Level of service for multi-lane highways, so same as freeway, so D is equals to VP over S. The definition of each level of service A through F is as follows. Level of service A, travel conditions are completely free flow. The only constraint on the operation of vehicle lies in the geometric feature of the roadway and individual driver preferences. Level of service B, travel conditions are at free flow. The presence of other vehicle is noticed but is not a constraint on the operational of vehicles, as are the geometric feature of the roadway and individual driver preferences. LOSC, traffic density begin to influence operation. The ability to maneuver within the traffic stream is affected by other vehicles. LOSD, the ability to maneuver is severely restricted due to congestion. Travel speeds are reduced as volumes increase. LOSE, operations are unstable and at or near capacity. Densities vary depending on the free flow speed. LOSF, a forced breakdown of flow occur at the point where the number of vehicles that arrive at a point exceeds the number of vehicles discharged, or when forecast demand exceeds capacity. Calculating the flow rate for a multi-lane highway. So, same ra sa ganiha. Ang formula kaning VP equals to V over PHF times N times FP times FHV. So, alright. Extended general segment in which the terrain is level, rolling, or mountainous. A specific grade. These are defined as segments that are less than 1.0 mile and 3% is greater than 3% and less than 0.5 miles and also less than 3%. So that's all. Thank you and God bless.